In this video, we are going to take some actual over 365 rates, although they could be actual over 360. The process is going to be about the same. So we're going to take some actual over 365 rates that we're given, and we're going to calculate the continuously compounded rate between the days. So we have a rate for 253 days, that's 4.73. And we have a rate for 380 days, that's 4.88. And we want to know the continuously compounded rate between 253 days and 380 days. The process I'm going to use to solve this is I'm going to calculate discount factors from my rates. I'm then going to calculate a forward discount factor by taking the ratio of the discount factors. And then I'm going to calculate the rate from that discount factor. We know the discount factor formulas, and so we're going to do a little bit of algebra in that last step to find the rate given the discount factor. Okay, so we need to calculate a couple of discount factors. Remember, these are actual over 365 rates. So the discount factor is equal to 1 divided by 1 plus the rate times the number of days divided by 365. If these were actual over 360 rates, we would use 360 here instead of 365. So the way we remember this formula is it's an interest calculation, right? So we think about it, if we turn it on its head and look at the future value, we do 1 over the discount factor. The future value of $1, the discount factor is the present value of $1. The future value of $1 is 1 over the discount factor. And if we look at this formula, it's equal to 1, the original $1, plus the rate times the number of days divided by 365. So it's 1 plus the interest we receive. So the future value of $1, if we invest it at 4.73 for 253 days, is 1 plus the rate times the number of days divided by 365. If we want the present value of $1, we do 1 over that. So that's where this formula comes from. So there's our first discount factor, and we can copy that formula to find our second discount factor. So we've got a discount factor for 253 days, a discount factor for 380 days. If we wanted to find the present value of a cash flow that happened in 253 days, we'd take the size of that cash flow times 0.9682547, and so on. Now, one thing to be careful with in all of these calculations is, generally speaking, you don't want to round intermediate steps. It's fine to round at the end, but rounding in intermediate steps causes some errors. So here, again, Excel's really nice. So if we do the calculations in Excel, then we get to keep the whole number here. Whereas if we did our calculations in our calculator, it might be a little harder. So I'm a big fan of using Excel as our calculator. Also, the nice thing about Excel is when I get the wrong answer, I can go look back and figure out what I did incorrectly. Okay, so those are my discount factors. The forward discount factor is the ratio of the longer dated discount factor divided by the shorter dated discount factor. So 0.982852, so the ratio, one over the other. Longer dated discount factor divided by shorter dated discount factor is the forward discount factor. Now it's relatively straightforward. We've got a formula, discount factor equals e to the minus RT. And so I can invert that. I'm going to do that in my head, but you could do some algebra on a piece of paper. Minus the natural log of the discount factor times 365. It's always 365 with continuously compounded rates, divided by the number of days. This forward discount factor takes $1 paid in 380 days and tells us what the future value is in 253 days. So it's valid. This discount factor is over the time period 253 to 380 days. That's what this rate is going to be valid for, between 253 and 380 days. So when we're inverting our formula, there's a days in it, and it's 380 minus 253. Let me reformat that as a date, or as a percent, sorry. Oops, not quite enough percent. Decimal places, 4 would be nice, 4.9712. Okay, so let me just recap. We were given actual over 365 rates. 253-day rate was 473. 380-day rate was 488. We wanted to calculate the continuously compounded forward rate between 253 and 380 days. Our process was take the given rates, calculate discount factors, 1 divided by 1 plus the rate times the number of days divided by 365. Calculate 2 discount factors, take their ratio, longer dated discount factor divided by shorter dated discount factor, invert the discount factor formula to get back a rate. In this case, we want a continuously compounded rate, so we're using e to the minus RT. That gives us the rate is negative natural log of the discount factor times 365 divided by the number of days, which in our case is 380 minus 253, giving us a rate of 4.9712.